Hi, my name is Morgan Simons, and I will be presenting a project on algorithmic bias that I completed with Kristen Corey. Basically, this project was inspired when Kristen and I found out that race labels or race data within the Duke University health system is flawed. So it is not a self-reported or self-identified field. It is rather a field that is assigned by front desk employees looking at patients and perceiving their race. This was a problem that was recognized in 2017 within the system and is now being slowly corrected. However, a model that was previously presented here at MLHC that I had worked on in the past had used what we now knew was a flawed label, this race label. And so we wanted to use this model to kind of probe a couple of questions about this flawed race data. So our main questions were, is there bias in this model in the form of unbalanced performance across subgroup populations? And in our case, the subgroup populations of interest were male and female and African American and Caucasian. And then if there were differences in performance across these groups, were there techniques or methodology that we could use to mitigate the bias? So our proposed experiments, the first were kind of post-training approaches. So one was what we call threshold modification. So saying typically when we set a threshold for the outcome being positive or negative, if we change this in subgroups, how will that, is there a difference in subgroups? Should we be picking different thresholds for positive and negative cases? And the other was a label flipping test. So after you've trained your model, if I change people's race or if I change people's gender, how is that going to impact performance? And then we also did some pre-training approaches in an attempt to mitigate what we knew was a flawed label before it is trained or used for training a model. And in that case, what we did was outcome label flipping, so changing people's races or genders prior to them being put through and trained. And the other is feature selection. And in our case, we've actually negated a feature. So if we remove race labels entirely, how does that compare to performance of our control, which is the original hyperglycemia model? And basically, after we performed these 4 experiments, we concluded that the race label does have an impact on model performance, and different subgroups have different and unequal performance. And so in our first experiment, we kind of determined that within the subgroups, you kind of have a different discretization between positive and negative cases. And so picking one threshold across all the groups is actually going to cause you to have more false positives or false negatives in some of the subgroups. And so maybe picking a different threshold with a given sensitivity and specificity that you want in individual groups is the better approach to take. In our second experiment, we kind of discovered that changing the label of one group to a higher performing subgroup can actually improve the performance within the other subgroup. In our third experiment, we determined that flipping the labels in a pre-processing way actually means that if you have a population that you believed is well tagged, which we actually believe that the African American population in our flawed race data is probably more accurate than the Caucasian labels. In those groups, they actually end up with poorer performance than in the control, likely because you're losing information by changing their label. And then in the fourth experiment, we trained on race. We trained without race labels entirely, and found that although it performed worse than the control, it's actually more accurate and equitable across the groups, and that closed the gap in subgroup performance. So thank you for listening, and I hope you look at our poster.